Hello, this is the second video in this video series for part 1 of this course, and today we'll be going over names, expressions, and variables. But before we start, I want to talk a little bit about setup. Whenever you are installing a new programming language or starting to work with a new programming language, there are a few things you have to install, and sometimes it's annoying, but with the right instructions, it's actually pretty smooth. So what I recommend is that you follow instructions from this website, which is basically the CS61A first lab. It's a setup lab, so I'll actually go to that right now. So the only part you need to read is the setting up and installing a terminal, installing Python 3, and installing a text editor. Everything else is specific to the course. And so a couple of notes. Installing a terminal, if you have Windows, they recommend that you use Git Bash. I personally use command prompt, which is right here. So this is every Windows computer should have command prompt, and Mac users have a built-in terminal. That's just fine. But the only reason you might want to use Git Bash is if you want to run Linux/Unix commands. If you don't know what that is, just stay with command prompt and don't worry about it. It's just fine. So the next thing you have to do is install Python 3. This website has video tutorials on how to do this, so that's pretty nice. Make sure if you're confused, definitely look at the video. It's a little more annoying for Windows to install Python, but make sure you install Python 3.4.3. Make sure you add it to the path. That's super important, because then you can work from the command line on running any types of Python programs. Okay, and the last part's pretty easy. Install a text editor. I recommend Sublime Text 2. It's really nice, and I haven't had any problems with it, so it's good. So yeah, that's all I have to say on that. Let's get started with the material. So the first topic is expressions, and expressions is anything that that we use that evaluates to a value. And there are really two types of expressions in computer science. A lot of them are things you've already seen in math, like just numbers, decimals, fractions, square roots. These are all expressions. There's also, obviously, words are also expressions. And in computer science, there's a special name for these type of things in quotes. It's called a string. So strings are anything in quotes. We'll be talking about strings a little later in the course. They're very interesting. And then lastly, the second type of expression we have is a call expression. We have, and basically call expressions, most of you have already seen functions, so anything that involves with functions is just a call expression. I'll be talking about functions later, but there are many built-in functions, and let me actually go through an example of this to make this more clear. So I'm going to run Python, and what I'm going to do is I'm going to show you some simple expressions like 5, 100.23 is an expression. Let's say I want to do simple division. This is technically a fraction, even though fractions, I don't know. They technically don't exist, but we'll call it a fraction for now. It's not a big deal. So then straight up decimals, also an expression. Strings, they can be done with either double quotes or single quotes. There's not really a difference. The only time you want to use double quotes is if there's an apostrophe in the string, and again, we'll talk about this later. Don't worry too much about that. So now, actual call expressions. So these are normal primitive expressions. Let me talk a little bit about call expressions, and to do that, I'm going to import some built-in functions from a module called operator. So you've probably seen me do this from operator import or from something import something notation a lot. And I think it's time I talk a little bit about it. Basically, every single programming language has some built-in features that make it very useful. And these built-in features are built into libraries. And in Python, they specifically call them modules. So operator is a very important module. Another module you see a lot is math module. So you can import things like square root from the math module, and you get access to the square root function. So another thing you can do, for those of you who just want to know, you can actually import everything from a module by doing the special asterisk syntax. But I don't recommend this because generally when you're working on projects, you want to specify exactly what you're importing from outside. And so this is just a lot more specific in my opinion. And generally it's a good programming practice to stay away from this. That's all I have on that. So let's actually look at some call expressions. So let's say I want to do a simple operation like 10 plus 20. If I want to do it with a call expression, I call the built-in function add on 10 and 20. If I want to do subtraction, I can do the same thing. I can just call sub on 10 and 20 and get negative 10. And then multiplication is done with the asterisk symbol. So same idea with call expressions. And now one thing I do want to talk about a little is true division versus floor division. So these are these two functions, okay? And basically, if I do 13 divided by 4, for example, I'll get 3.25, which is exactly what it is, okay? And the call expression equivalent of this is to just call it on these two arguments. And then, from here, let's see what happens if I do floor div 13 and 4. Let's just to see what the difference is. Okay, so we get 3, okay? Let's say I want to do true div or 19 divided by 4. That gives me 4.75. I'm going to do floor div of 19 and 4. What happens? I get 4. So basically, as you can see, what floor div does is it basically cuts off the end of this decimal. So if you have some 5 point something something something, the floor div version of that is going to give you 5. And then so it might be annoying to type floor div out, so there's a shorthand notation for that. You just use 2 division signs and you would get the same thing. Okay, so then you might ask, hey, what's the use of floor div? Why would they ever use something like that? And floor div is very useful in one specific type of problem, which I'll show you. So let's say I have the number 123, and I want to get the first 2 digits of that number. That's 1 and 2, right? So if I want to get 1, an easy way to do that is actually to do floor div by 100. And if I want to get 2, an easy way to do that is to get floor div 10 and then do something called a modulus, which takes the remainder of something by 10, and I'll get 2. Okay, so this is something, so I'm throwing a lot of stuff at you. Modulus is basically, if given a number, it'll take the remainder of that number when you divide it with, so the remainder of 13 divided by 5 is 3, so this will give me 3. Okay, so yeah, I've thrown a lot at there. Don't feel free to look back at that and see if there's anything that confuses you. So this is why floor div is useful, especially with anything that involves digit by digit operations. Floor div is extremely useful. You'll see it all the time. Okay, so that's basically the rundown of expressions and call expressions. So one thing I want to talk about is a little bit of vocabulary with relating to call expressions. So here we see our primitive expressions right there. Now a way to do this with a call expression is to call the built-in function add, and then what we have is every single call expression has something called an operator. So here it's a function, which is the operator, and then it has operands. So operands are basically the arguments in which the function is called, and here add is given 2 arguments. Sometimes it can be given more. So those any type of arguments are called operands formally. So now I'm going to talk about the evaluation procedure for call expressions. And this might seem a little over the top because you're like, hey, I'm just adding 2 numbers. Why do I need to do all this? But trust me, it's going to be useful, as you'll see in an example that I'm going to show you soon for more complicated expressions. So basically what we do with any call expression is we take our operator, we evaluate it, then we evaluate the operands, and then we apply the operator to the operands. So here what I'm going to do is, so then you might ask, hey, what does it mean to evaluate an operator? So let's say here, my operator is add. What is add? It's a built-in function add. So now the Python interpreter knows that add is a built-in function. So once it evaluates that and knows it's a function, it then checks what the operands are. So here it's just 10 and 20. 10 and 20 are just 10 and 20. You can't really go any further than that. And then you apply the function to the operands. And so you just add 10 and 20, you get 30. Okay, so I know I'm being very detailed here, but this is important because you'll see why in this example. So let's say that you have this very, very, very complicated expression. Okay, how would you go about decomposing this? So the way we would do that is take our rules that we learned here and apply them over and over again until we get our answer. And I'll show you that. And the best way to do this is use something called an expression tree. Okay? So the first thing we do is, so we're trying to figure out what this entire expression is. So let's first, well, this is a call expression at the end of the day. We have an operator here, and then we have one operand here, and one operand here. Okay? So the evaluation of this operator is add. Okay, cool. And then here, we evaluate this operator, and it ends up being another call expression. Okay. And then same thing here, we have a much larger call expression, but still a call expression nonetheless. Okay? So, let's keep on going. Same idea, we evaluate the operator, we evaluate the operands. So here, in this case, 2 and 3 end up being just 2 and 3. So we're done here. And then we evaluate the operator. The operands are these expressions. So we just pull them down. So this is evaluating the operands. And then now here we have two call expressions. We have to go a little further. So we do the same process. 10 is just 10, but we have another call expression here. So we're done here as well. So you can kind of see the pattern. We're just doing the same thing over and over again. And once we get to the simplest possible case where we just have built-in functions and numbers, we can now build ourselves up. So this is kind of an inverted tree, okay? And in computer science, we really like to call inverted trees just trees, okay? Because it's kind of annoying to say inverted trees all the time. So it's just like an upside down tree. Okay, and so now we're going to go from the bottom layer and we're going to build ourselves back up. So this is now, right, what we've done so far, I want to show you real quick. So hold up. So we've evaluated the operator and we've evaluated the operands. And once we've done that, we can now apply the operator to the operands. So I'm going to show you what this means. So once we're down here, so now we've got our multiplication function. We need to apply it to 10 and 1. Okay, what's 10 times 1? It's 10. Okay, so now we go to the next level. So we have multiple expressions now. We're going to subtract 10 and 10, we get 0 there, and we're going to multiply 3 and 5, we get 15 there. Okay, so we get 0 and 15. Okay, so now we go this level. Okay, so multiply 2 and 3, get 6, and then add 0 and 15. So what I'm doing is I'm going straight across the middle. So I'm literally saying multiply 2, 3, add 0 and 15, and I get this, and then lastly I have add 6 and 15, and I get 21. So this entire expression, by using this expression tree, we get 21. Okay, so so that's an example of repeatedly applying a process to get an answer. And I know before I go into the next topic, I know this seems a little tedious to solve something like this. You probably could have figured it out by just analyzing the structure of this, or going some inner outer methods, but I want to say that this is a method that will always work, and this is how the Python interpreter actually does this. It's something called a recursive process, which recursive process is something we'll talk about a lot more in this course later. But yeah, I want to show you this method because this is how the Python interpreter does it, and this is also a surefire method that will get it right every time.